The average homesteader spends roughly $400 a year on commercial fertilizer. Meanwhile, they throw away the single best soil amendment on Earth, every day, straight into a trash bag. Kitchen scraps, yard waste, livestock bedding, cardboard. All of it is free fertilizer. You just need to know which method turns it into something your soil can use. Every method on this list takes waste you already produce and converts it into nutrient-rich compost, for free. Some take 6 months. One takes 18 days. Another lets you compost meat and dairy, something most people think is impossible. And the last method on this list will feed your soil for 20 years without ever adding another bag of anything. 8 methods. We are going from the laziest to the most productive. Let us start with the one that requires almost zero effort. Method 1. Cold composting. The pilot and forget it method. Cold composting is exactly what it sounds like. You make a pile of organic material, kitchen scraps, leaves, grass clippings, straw, and you leave it alone. No turning, no monitoring, no thermometer. You just keep adding material to the pile and let nature do the work. Bacteria, fungi, insects, and earthworms break everything down slowly over 6 to 12 months. The advantage is obvious. It requires almost no labor. Throw your scraps on the pile, walk away, come back in a year. The disadvantages are equally obvious. It is slow. It does not get hot enough to kill weed seeds or pathogens. And if your carbon-to-nitrogen ratio is off, too many greens, not enough browns, the pile will smell. The rule of thumb is roughly 30 parts carbon to 1 part nitrogen by weight. In practical terms, that means for every bucket of kitchen scraps, add 2 to 3 buckets of dry leaves, straw, or shredded cardboard. Cold composting is perfect if you have space, patience, and no rush. It is not the method for someone trying to build garden beds by spring. Method 2. Hot composting. The 18-day turnaround. Hot composting is cold composting with a schedule and a thermometer. You build the pile all at once, not gradually, using the same 30:1 carbon-to-nitrogen ratio, but in a specific layered structure. Then you turn it on a strict rotation. The classic approach is the Berkeley method, developed at the University of California. Build a pile at least 1 cubic meter in size. Alternate layers of greens and browns. Water each layer until it is damp, like a wrung-out sponge. Then turn the entire pile every 2 days. Within 24 to 48 hours, the internal temperature climbs to between 55 and 65 degrees Celsius, roughly 130 to 150 degrees Fahrenheit. That heat is generated by thermophilic bacteria consuming the organic material at an accelerated rate. Think of it as the difference between a slow cooker and a pressure cooker. Same ingredients, dramatically different speed. At sustained temperatures above 55 degrees Celsius, weed seeds are killed, most plant pathogens are destroyed, and the pile breaks down into finished compost in as little as 18 days. The trade-off is labor. You are physically turning a large, heavy pile every 48 hours. You need a thermometer to monitor internal temperature, and if the pile drops below temperature, you may need to adjust moisture or add more nitrogen-rich material. Hot composting is the fastest method on this list that produces true finished compost. If you need soil by planting season, this is it. Method 3. Tumbler composting. Contained and clean. A compost tumbler is a sealed barrel mounted on a frame that lets you rotate the entire container by turning a handle or spinning it. The concept is hot composting in a controlled environment. You load the tumbler with greens and browns, seal it, and spin it every day or two. The sealed design retains heat and moisture better than an open pile, keeps pests out completely, and produces no odor if managed correctly. Most tumblers produce usable compost in 4 to 8 weeks, slower than the Berkeley method but faster than cold composting, with significantly less physical effort than turning a ground pile with a fork. The limitation is volume. Most home tumblers hold between 150 and 300 liters. That is enough for kitchen scraps and light garden waste. But if you are composting livestock bedding, large amounts of hay, or clearing an entire garden at the end of season, a tumbler will not hold it. You will need a ground pile for the heavy material and the tumbler for the kitchen stream. Tumblers range from $80 to $250 depending on size and build quality. The investment pays for itself within one growing season if it replaces bagged compost or fertilizer purchases. Method 4. Vermicomposting. Let the worms do the work. Vermicomposting uses red wiggler worms, Eisenia fetida, to convert organic waste into worm castings, which are among the most nutrient-dense soil amendments you can produce at home. The setup is simple. A worm bin, either purchased or built from stacked plastic containers with drainage holes, is filled with damp, shredded newspaper or cardboard as bedding. You add roughly 500 to 1,000 red wigglers. Then you feed them kitchen scraps, fruit peels, vegetable trimmings, coffee grounds, crushed eggshells. The worms eat roughly half their body weight in food per day. A healthy bin of 1,000 worms processes about 1 pound of kitchen waste every 2 days. The output, worm castings, has an NPK ratio of roughly 5 to 5:3 and contains beneficial microbes that improve soil structure, water retention, and root health. The biggest advantage of vermicomposting is that it works indoors. No yard required. A well-managed worm bin does not smell. It should smell like forest floor. It produces usable castings in 2 to 3 months. The rules: no meat, no dairy, no oily food, no citrus in large amounts. These either attract pests or harm the worms. Temperature matters. Red wigglers thrive between 15 and 25 degrees Celsius. Below freezing or above 35 degrees, they die. If you want the highest quality compost per pound of input, vermicomposting wins. Nothing else on this list matches the nutrient density of worm castings. Method 5. Bokashi composting. The one that handles meat and dairy. This is the method we teased at the beginning, the one that breaks the rules. Bokashi is a Japanese fermentation method. It does not decompose food, it ferments it. The same basic process that turns cabbage into sauerkraut or cucumbers into pickles. You layer food scraps, including meat, fish, dairy, cooked food, and bones, into an airtight bucket. Between each layer, you sprinkle Bokashi bran, wheat bran inoculated with effective microorganisms. You press the scraps down to remove air, seal the lid, and leave it for roughly 2 weeks. Inside the sealed bucket, anaerobic bacteria ferment the material. No oxygen. No smell, or rather, a faint sweet-sour smell, like vinegar. The bucket has a spigot at the bottom that drains a liquid byproduct called Bokashi tea, which you dilute and use as a liquid fertilizer. After 2 weeks, the fermented material is not finished compost. It looks almost the same as when you put it in, just pickled. You bury it in a trench in your garden, or add it to an existing compost pile. Underground, it breaks down into true compost within 2 to 4 weeks. The advantage is scope. Bokashi handles everything: meat scraps, cheese rinds, fish bones, cooked rice, waste streams that every other method on this list cannot process safely. For homesteads processing animal products, this is the only indoor-compatible option. A basic Bokashi kit costs $30 to $50. The brand needs replenishing, roughly $10 to $15 every few months. Method 6. Trench composting. No bin, no pile, no equipment. Trench composting is the most primitive method on this list, and one of the most effective for direct soil improvement. Dig a trench or a hole roughly 30 centimeters deep. Fill it with kitchen scraps, garden waste, or any organic material. Cover it with at least 15 centimeters of soil. Walk away. The soil organisms, bacteria, fungi, earthworms, do everything. No turning, no monitoring, no bin. The material decomposes underground over 2 to 6 months and enriches the soil directly where your next crop will grow. Many homesteaders rotate trench composting through their garden beds on a 3-year cycle. Year 1, you dig and bury. Year 2, you plant a heavy feeder like tomatoes or squash directly over the trench. Year 3, you plant a light feeder or a nitrogen fixer like beans. Then you dig a new trench. The limitation is speed. It is slow, and you cannot use the burial area for planting until decomposition is well underway. But the cost is zero, the labor is minimal, and the nutrients go directly into the root zone. Method 7. Black soldier fly composting. The fastest biological processor. Black soldier fly larvae, Hermetia illucens, are the most aggressive decomposers available to a homesteader. A colony of BSF larvae can process organic waste 2 to 5 times faster than red wiggler worms, and they handle a wider range of inputs, including meat, dairy, and manure. The setup is a ventilated bin with a ramp structure that allows mature larvae to crawl out and pupate. You feed kitchen scraps, livestock manure, or garden waste into the bin. The larvae consume the material rapidly. A well-established colony can process several pounds of waste per day. The output is 2 things: a nutrient-rich residue called frass, which functions as a balanced fertilizer and soil conditioner, and the larvae themselves, which are roughly 40% protein and can be fed directly to chickens, ducks, or fish. That dual output, fertilizer and animal feed from the same waste stream, makes BSF composting one of the most efficient closed-loop systems on a homestead. Your kitchen scraps feed the larvae feed your chickens. The chicken manure goes back into the compost. Nothing leaves the property. The limitation is climate. BSF larvae thrive in warm environments, ideally above 25 degrees Celsius. In cold climates, the system either shuts down in winter or needs to be moved indoors. Method 8. Hugelkultur. The 20-year soil battery. Hugelkultur is a German and Eastern European technique that buries large volumes of wood, logs, branches, stumps, under a raised garden bed. The wood decomposes slowly over years, acting as a long-term nutrient source, a water reservoir, and a habitat for beneficial fungi. The construction is straightforward. Lay logs and large branches on the ground, stack smaller branches and brush on top. Add a layer of compost, manure, or kitchen scraps. Cover everything with soil. Plant directly into the mound. In the first year, the wood absorbs nitrogen from the soil as it begins to decompose, so heavy-feeding crops may underperform. By year 2, the decomposition releases nitrogen back into the bed. By year 3 and beyond, the bed becomes self-sustaining. Think of it as an underground battery. The wood stores water. A single Hugelkultur bed can hold enough moisture to reduce irrigation by 50 to 70% in dry climates. As the wood breaks down over 10 to 20 years, it continuously releases nutrients, creates air pockets for root growth, and supports a thriving fungal network. Hugelkultur is not fast composting, it is infrastructure. A well-built bed will feed your soil for a decade or more without any additional fertilizer input. The trade-off is upfront labor. Building a Hugelkultur bed requires sourcing large amounts of wood, digging, layering, and covering. It is a weekend project, not a quick fix. But the return over time is unmatched by any other method on this list. 8 methods. From a lazy pile that takes a year to a buried wood bed that feeds your soil for 20. Here is the practical takeaway. Most homesteads benefit from running 2 or 3 of these systems simultaneously. A cold pile or tumbler for yard waste, a worm bin or Bokashi bucket for kitchen scraps, and a trench or Hugelkultur bed for long-term soil building. The fertilizer aisle at the garden center exists because people do not realize they are already producing everything their soil needs. Now you know how to use it. If this was useful, subscribe. We break down the systems that make a homestead actually work. But composting is only half the equation. The other half is understanding what your soil actually needs. And most homesteaders have never tested theirs. How to read a soil test, what the numbers mean, and how to fix deficiencies without spending $1 at the store. That is exactly what we are covering next.